Hello Math 250B students. I am here to carry out on my promise that I said that I would give you an additional example of first order linear differential equations to study, because I know we only had a chance to do one example at the end of class, and I want to make sure you have enough of an idea about how to carry this out. And it's not a bad idea to just give you a quick summary as well of the process, and this won't take very long, and hopefully it'll help you with understanding this section on first order linear differential equations. So just as a quick reminder, here's the form of the differential equation. It's first order and it has the form of a linear equation. So we have a method, and I kind of broke it into 3 steps for you. This is really the nuts and bolts of what you actually need. In class I kind of derived everything and went through all the details, but here this is just kind of the summary. So the first thing is that you have to have an integrating factor. And we have a formula for that. That's this I right here. Integrating factor e to the integral of p of x dx. P of x being the thing that's multiplied in front of the y, right? So we find that integrating factor. And then we can simply go to step 2, which is that we have a product rule. The derivative of the product, I times our unknown function y, has to equal q times I. So we can just literally write that down. We don't have to derive it. It's just something we can go straight to that and write it down. But from there, we just solve for y, and to be able to do that, we just have to remove the derivative and then divide by I. Then, in other words, we have to integrate on both sides and then divide through by I, and we're going to get what the unknown function y is. So here's an example we can practice on up here. Y prime, this one has trig functions in it. Y prime equals sine of x times the quantity y times secant of x minus 2. And I meant to include a condition here. Because we have these trig functions, let's assume that x is in the first quadrant of the trig plane, so that all trig functions are positive. I'm not going to worry about any negative expressions there. So the very first thing we really need to do is rewrite this equation in the form of a first order linear differential equation. So let me do that for you really quick. So we have the y prime right here, okay? Incidentally, secant of x is really just 1 over cosine of x. So if I want, I can take sine of x and divide it by cosine of x and just rewrite that as tangent of x. So I'm going to do that, tangent of x times y. And then don't forget there's another term here, minus 2 sine of x. Okay, so I really just multiplied it out. And I simplified sine times secant as just tangent. Now this is still not the right form, because as you can see from the form up here, the y that is appearing here has to be on the left side of the equation. So let me just subtract that over right now. Give me, whoops, I'm not subtracting it properly. Here's my eraser. So I'm going to subtract the y over. So this will be y prime minus tangent of x times y equals negative 2 times the sine of x. That's how it should look, right? Okay. From there, now I can clearly see p of x from this form, right? The p of x up here, be careful, there is a minus there. You need to include the minus into the p of x because there's a subtraction. And q of x is equal to negative 2 times the sine of x, like that. Okay? So we have p of x, we have q of x, and that's where we're starting from. So the next thing we need to do is write down the integrating factor. So that's e to the integral of negative tangent of x dx. And I can, of course, pull out the minus sign. The integral of tangent can be done by using a u substitution. It's something that you probably saw in Math 150B. But it's also going to be in the table that's in the front of the book, which you can look at anytime you like. So the formula for this is it's negative the ln of cosine of x. It's a little bit complicated. And remember that I don't have to put a plus c on that. It's because we're only trying to find one acceptable integrating factor. Any integrating factor will work, including this one here that does not have the plus c on it. So I'm just going to leave it like that. Notice that the two minus signs cancel, and then the e and the ln cancel, and I'm left with just cosine of x as my integrating factor. Okay, so that's pretty nice. Okay, great. So that's kind of the first step. We write down the integrating factor. Now I'm going to come over here and see if I can squeeze some of the rest of it into this space right here. The next thing in step 2 is we just simply write down the integrating factor, cosine of x, times the unknown function y, derivative of that equals, and then on the right-hand side of the equation, we put q times I. So the q was negative 2 sine of x, and the I was cosine of x. Okay? Now we're ready for step 3, which is just to integrate both sides and divide by I in order to solve for y. So when I integrate both sides, I'm going to cancel the derivative from the left side. So I'm integrating here. And on the right-hand side, when I integrate, I'm just going to do this as a u substitution. So I have a negative 2 as a constant. And then this is just u du, right? The derivative of sine is cosine, so u du. So the integral of that would be sine squared of x over 2. And this time I do need a plus c on that. Okay? And if I want, I can cancel these 2's. So negative sine squared of x plus c, like that. And now I solve for y very easily. I just have to divide by cosine of x. So negative sine squared of x plus c all over cosine of x. So there is my final answer. I want to point out here, I didn't need to use any absolute value bars anywhere in the solution. For example, back over here when I used the ln of cosine of x, remember I restricted x to be in the first quadrant, so I know that cosine of x is positive, so there's no need to put absolute value bars around it. So the absolute value bars never really become important, and we just end up with this as our final answer. Anyway, I hope that that was helpful to see, first of all, the bare bones summary of how to do these problems, and then another example showing how that process works out. If you have more questions about first order linear differential equations, of course I'm happy to help. You can ask me anytime, and hopefully this will help the upcoming homework assignment to be more straightforward for you. Okay, thanks a lot. Appreciate your attention.